In today's lesson, we're going to be talking about the derivatives of sine and cos. For our first proof here, we want to show that the derivative of sine of x is cos of x. Recall, we have our general definition of a derivative. F prime at x is going to be the limit as h goes to 0 of f at x plus h minus f at x over h. So we're going to apply that for our sine function. Now we want to be able to use our limit properties and break this up. So we're going to focus our attention on the sine of x plus h and expand this out, in which case we get the limit as h goes to 0 of sine x cos h plus sine h cos of x minus sine of x all over h. We're going to go ahead and group together sine x cos h and the minus sine x together. Rearranging this and breaking this up, we get, notice here I grouped these two together and put them over h, and likewise I took the limit of the sine h cos x over h. Now you notice this is a limit as h goes to 0. It has nothing to do with the variable of x. Likewise, this has nothing to do with the variable of x here, so I can factor out a sine of x out of this first limit and a cos of x out of this first limit, in which case we end up getting the limit as h goes to 0 of cos of h minus 1 over h, and the limit as h goes to 0 of sine h over h. Well, in the previous lesson, we had shown that this was 0, and we had shown that this was equal to 1. I'll go ahead and link that lesson in the top right-hand corner if you do need it. And now because of that, what happens here is obviously we have cancellation here. This becomes 0, and this simplifies to become just the cos of x. So therefore, in summary, if f at x is the sine of x, then we know its derivative is going to be the cos of x. Let's go ahead and take a look at what the derivative of the cos of x is. It turns out that the derivative of the cos of x is negative sine of x. To see this, we make the following observation. Consider a unit circle and consider two different terminal arms. One has a measure of x, in which case this point here would be defined as cos x sine of x, and the other has a measure such that the measure from here to here would be equal to the measure from here to here, which is pi over 2 minus x. So therefore this point here by definition would be the cos of pi over 2 minus x, comma, the sine of pi over 2 minus x. Now what does that mean? Well, that means the length from here to here, by our definition, is going to be the sine of x, and likewise the length here will be the cos of x. Also, compare that with the triangle we have here. Well, these two triangles are congruent. It's the exact same triangle. Notice they have the same measure x. They both have right angles at these points here, and therefore the third angles are equal. Also, they share the same hypotenuse, so the triangles are congruent. Because of that, we therefore know that this length here is going to equal this length here, and likewise, the length from here to here will also equal this length here. But the length from here to here is the cos of pi over 2 minus x, and the length from here to here, by definition, is the sine of pi over 2 minus x. So therefore, because of this, we know that the sine of pi over 2 minus x, that will be this length here, must equal the cos of x. From this, we also know that the cos of pi over 2 minus x equals the sine of x. With these two results here, let's take a look at taking the derivative of the cos of x. Well, the derivative of the cos of x, it would be equivalent to taking the derivative with respect to x of the sine of pi over 2 minus x. But as we know here, the derivative of the sine of x is the cos of x, so this would be the cos of pi over 2 minus x times, using the chain rule, we have to take the derivative of the inside, which is negative 1. But we also know the cos of pi over 2 minus x is equal to the sine of x. So we end up getting the derivative of the cos of x is negative sine of x. Let's take a look at applying these derivatives to some questions. For our first question here, we want to take the derivative of the sine of 3x. Well, we know the derivative of sine is cos, so this would be the cos of 3x times, applying the chain rule, the derivative of the inside is 3. So dy dx is going to be 3 cos 3x. Moving on to example 2 here, same idea. I go ahead and take my y prime here. I know the derivative of cos of x is negative sine of x. So this will be negative sine of the inside. And again, applying the chain rule, I have to take the derivative of the inside, which is 2x. So in this example, the derivative will be negative 2x sine of x squared plus 2. Moving on to example 3 here, we see that y prime is going to be the cos of x cubed times the derivative of the inside is 3x squared. For this problem here, we're raising the sine of x to the power of 3. So really this is the sine of x cubed, in which case I can take my derivative. We're going to first treat this as the power rule. So you drop down the 3, subtract 1, and then we have to go ahead and take the derivative of the inside, in which case the derivative of the sine of x is the cos of x. For this example here, we want to find y prime. Notice now that we're going to use the product rule. We have the x squared times cos of x. So in this case here, y prime is going to be your first times the derivative of cos of x is negative sine of x plus your second term times the derivative of the first is 2x. So in this case here, y prime is going to be negative x squared sine of x plus 2x times the cos of x. For the next example here, we want to find y prime. Notice I have 3 terms here, and you could treat this as the product rule. You could kind of group these together and do the product rule for this, but instead what I'm going to do is I'm going to use the fact that I know that the sine of 2x is equal to 2 sine of x cos of x. So therefore what I can do is I can rewrite this, and I know therefore the sine of x cos of x must equal the sine of 2x divided by 2. So doing that, we can kind of get rid of sine x cos of x and replace it with a simpler derivative to take. And now here, this just becomes the product rule. So making this a little easier to read, we have y equals 1/2 x times the sine of 2x. So now if I want to go ahead and take dy dx, you're going to go ahead and do your first times the derivative of sine of 2x is going to be the cos of 2x times the derivative of the inside is 2, plus your second term, so sine of 2x, times the derivative of 1/2 x is a half. Cleaning this up here, we get dy dx is going to equal x cos of 2x plus 1/2 the sine of 2x. Let's take a look at this one. So for this example here, we're going to go ahead and take y prime. Now y prime is going to be the derivative of sine is cos. So this would be the cos of x. Notice we're treating this as your angle, right? It's the derivative of sine is cos, and then we write this back down. Now I have to go ahead and take the derivative of the inside. Well, the derivative of the inside is going to be the derivative of cos, in which case the derivative of cos is negative sine x. So in this case here, y prime is negative sine of x times the cos of x. Moving along here, we want to take a look here and find the equation of the tangent line to this curve at this point. So in this case here, we're going to find our derivative. Notice here to go ahead and take our derivative, we're going to use the quotient rule. So it's going to be the bottom times the derivative of the top is cos of x minus your top times the derivative of the bottom is going to be negative sine of 2x times 2. Again, the derivative of cos of 2x is negative sine of 2x times the derivative on the inside is 2. Take that entire expression and divide it by the bottom squared. Now we just want to find the slope here, so I just have to set this equal to pi over 6. And again, here I just subbed in my values here. Cos of pi over 3 is a half, etc. Sub those all in here, and now we're going to go ahead and simplify. Simplifying this, we get root 3 over 4 plus 2 root 3 over 4, all divided by 1 over 4, which ends up being here 3 root 3 over 4 divided by a quarter, which is equal to 3 root 3. So therefore, the slope of this line is 3 root 3. Let's go ahead and find the equation of this. So subbing our slope in here, we get y equals 3 root 3 x plus my y-intercept. Notice the corresponding point here was pi over 6 and 1. So I'm going to sub the point pi over 6 and 1 into the expression, and we end up getting 1 equals 3 root 3 times pi over 6 plus my y-intercept. So therefore my y-intercept here is going to equal 1 minus 3 root 3 pi over 6. Getting a common denominator here, we end up getting 1 minus root 3 pi over 2, which is 2 minus root 3 pi over 2. So the linear equation, y equals 3 root 3x plus 2 minus root 3 pi all over 2. If you wanted to express this in standard form, we can multiply across by 2, in which case we get 2y is 6 root 3x plus 2 minus root 3 pi. And finishing this off here, we end up getting 6 root 3x minus 2y plus 2 minus root 3 pi equals 0. So in standard form, this would be the equation to the tangent line to the curve y equals sine x over cos 2x when x equals pi over 6. That concludes today's lesson on taking the derivative of sine and cos. Thank you.